Good morning, everyone. Thank you for joining us today, and welcome to the third of our webinars on the world's best fuels refineries. My name's Ian Tenner. I work with Solomon as a senior consultant out of the UK office. In a moment, I'll be handing over to my colleague Paul Cole to deliver the presentation today. Paul is the data analysis product manager at Solomon. He has over 25 years of industry experience and has been with Solomon for the last 8. Before I hand over to Paul, there's just a few admin items. For confidentiality, you'll be muted for the webinar. If you do have questions, there is a Q&A button at the bottom of your screen. This will open a window where you can type them. You'll also be able to submit questions as we go along, and we have time allocated at the end to review as many of these as possible. If we're unable to answer your question on the call today, we'll try to follow up afterwards using the email that you've registered with. Finally, we'll send out a recording of the presentation to you in around a week's time. So enough from me, over to you, Paul.
Good morning. Thank you for taking your time out of your day to join me for this webinar. I hope that you and your families are safe and well during these unsettled times. Like you, all of us in Solomon have become much more flexible in our support to our clients. Fortunately, many of us are used to working from home, and we have the infrastructure already in place to provide many of our services remotely. This webinar is no exception. We appreciate that our business is facing extraordinary challenges due to the overall market slowdown and the resulting demand destruction. Now, more than ever, the decisions made by you and your companies will set the scene for recovery after all of this is over. In our role as a trusted Solomon advisor, we continue to use our extensive historical database and our expertise to allow companies to make data-driven decisions. Our research into the world's best refineries is a great example of this, and we would be happy to work with any of our clients to leverage that insight. The slide you see before you is our proprietary statement. This is a gentle reminder that the methodologies you see throughout this presentation are proprietary to Solomon and may not be used without written prior permission. This slide will be covered again towards the end of the presentation, but I felt it was an important reminder why looking at the world's best refineries can help all of us during these turbulent times. The cost of transportation fuels has been used by Solomon for a number of studies as a way to assess survivability within the refining industry. The cost of transportation fuels is a function of raw material costs, which of course includes crude price, operating costs, and by-product revenue. So by-products are refinery production that is not a transportation fuel, such as gasoline, jet, and diesel. As crude price falls, the importance of low operating costs becomes more important. And you can see on the slide how the world's best refineries move into first quartile as the cost of crude oil is reduced. I will show later that the world's best refineries have a relentless focus on reliability. They seek to minimize non-turnaround downtime. They are proactive with their maintenance. They prevent failures before they occur. This helps them to minimize maintenance cost and allows refineries to operate with fewer staff and contractors on site. History has proven that times of crisis drives innovative thinking. World's best refineries have studied the lessons of the past. They understand how to be competitive when margins are depressed. They understand that the control of costs is really important. And we know from their investments that they do not stop spending in the areas that matter the most to the long-term growth. All good operators realize that the control of costs is more than just how much you spend, but more importantly, what you're spending it on. The presentation today is a very short summary of a much larger piece of analysis that we've conducted on our database of over 330 refineries worldwide. The full presentation is available to all of our study participants for a very small fee. We can add your data to any of the slides and offer you insights on how you too can transition to be a world's best refinery. In today's presentation, I will describe our selection criteria and why we believe this characterizes the world's best refinery. Then I will show you how the world's best perform against the rest of the world and explain what makes them different. So first, to be considered a world's best refinery, you need to have top half performance in 4 key metrics. Operation availability is a measure of the reliability of your refinery. Return of investment, this is a measure of the economic performance of your site. Energy intensity index is a measure of the energy efficiency of your process units. And maintenance cost efficiency index is, of course, a measure of maintenance cost. But it does not stop there. The world's best refineries need to sustain this performance over 3 studies, which is 6 years. In the end, we found only a small number of refineries met this criteria, and we selected 4 from North and South America, 4 from Europe, and 4 from Asia Pacific. This slide shows the quartile performance for 11 of our key Sullivan metrics. Where you see 1 or green, this is first quartile. Where you see 2 or yellow, that is second quartile. You will also see 2 columns of data. On the left is the world's best peer group, and that is the 12 refineries that we've already discussed. On the right is a world's best trend group, which is a slightly smaller subset of the 12 refineries, so 10 of these refineries that have participated for 7 Solomon studies in a row. So that means 14 years. We will use this group later in a number of the trends. In many metrics, both groups, the world's best and the world's best trend, are first and second quartile. The one exception is non-maintenance personnel. Later I will show that this is due to a small number of low-wage refineries with very high personnel numbers. When you remove these refineries, the remaining refineries, which is 10 in total, are close to first quartile performance. The top of the table is our 4 primary selection criteria. So of course we expect them to be first and second quartile. But the remaining 7 metrics highlight that with the right strategy and enough time, you could be at or close to first quartile performance in many areas and sustain it. At this stage, I'm sure many of you are listening to the webinar and believe that the refineries we've selected to be in the world's best peer group are special. They are not. In fact, many of the world's best refineries are just like any of the refineries each of you have worked at throughout your careers. They are mostly FCC conversion refineries, and there are only 3 coking refineries in the selection. Size and complexity does not matter. 4 out of the 12 world's best refineries have less equivalent distillation capacity than the average of the rest of the world. Location doesn't matter. 50% of the refineries worldwide are in the same country as the world's best refinery. And as I mentioned in the previous slide, age doesn't matter. We've got 10 of the world's best refineries that are over 14 years old. So this is pretty disappointing so far. You've attended this webinar to find out what is different about this group. So let's now look at investment. Surely there's been a lot of recent investment at these refineries to make them the world's best. Well, sadly not. More than half of the refineries in the world's best peer group invest less than average. However, looking at the investments made by a refinery today does not explain why they are the world's best. There is much more insight to be gained whenever you look at the story why. We notice, for example, that the world's best refineries invested much earlier in clean fuels than the rest of the world. World's best refineries have made the right investments at the right time in their history to ensure that the configuration of their refinery is a good economic fit for the current and future economic environments. So next we want to look at some of the key performance metrics for world's best refineries. And the first one we want to look at is operational availability. So of course, operation availability is one of our primary selection criteria, so we do expect it to be somewhere in first and second quartile. But more than half of the world's best refineries are actually in first quartile. We can break operational availability into two components. The first to look at turnaround and the second to look at non-turnaround downtime. The slide before you is for turnaround, and it shows that there's an average difference of around 0.4%. We can also break out turnaround by region, so we can look at Europe, North and South America, and Asia Pacific. And you can see that Europe and Asia Pacific perform much better than the rest of the world. But the same is not true for North America. To understand why, you need to go a little bit deeper. So we can break out turnaround unavailability into turnaround downtime, which are the days shut down for a turnaround event, and the turnaround interval, which is the period of time in years between two turnaround events. You can see from the chart on the left, which says interval, that North America has focused on increasing the interval between events. But on the chart on the right, you can see that Asia Pacific and Europe have reduced the days that they were shut down. World's best refineries that focus on duration rather than interval had better overall results. This slide now looks at the other side, which is non-turnaround downtime. The difference between the world's best refineries and the rest of the world is much more apparent for all three regions. There's a 0.9% difference on this chart, whereas if you remember from the turnaround chart, the difference was 0.4%. Whilst world's best refineries plan and execute their turnaround events to be as short as possible, they do not do this at the expense of process unit reliability between turnaround events. Next, we want to look at process utilization. So process utilization is extremely important for both economic performance as measured by return of investment and for energy efficiency. Process utilization is a function of two things: having the right design and configuration for your economic environment and operating your refinery well. In other words, having good operational availability and making the right economic choices. I mentioned previously that world's best refineries have made the right investments at the right time in their history to ensure that the configuration of their refinery is a good economic fit for current and future economic environments. We've also just covered the reasons why world's best refineries have higher operational availability. So it is no surprise that 7 out of 12 refineries have first quartile process utilization. So I believe that operation availability is the primary driver to becoming a world's best refinery. Without good reliability, you can never be the world's best. Without high reliability, you will not have high process utilization, and that is crucial for both energy efficiency and return of investment. We have not yet mentioned maintenance efficiency, and this was one of our 4 selection criteria. Refineries with high operation availability will have low maintenance cost. With high operation availability, maintenance planning is proactive and it is not reactive. Because of this, the world's best peer group will have entered into 2020 in a much better position to survive this downturn and to operate with reduced resources on site. Many companies in the world today are actively looking to reduce carbon emissions. One of the best ways to do this is to improve energy efficiency. EII, or Energy Intensity Index, is Solomon's proprietary metric to measure energy efficiency and is one of the leading metrics used by companies and government agencies throughout the world today. Energy Intensity Index is a primary selection criteria, so again, we expect to see the blue diamond somewhere in the first and second quartile. However, just like operation availability, more than half of the refineries in the world are first quartile. I mentioned already that process utilization and energy intensity index are closely linked. The dotted lines on this chart show Solomon's rule of thumb, linking a 2% increase in utilization to a reduction of 1% in energy intensity index. The world's best trend on the left does well to demonstrate this relationship. However, the reduction in energy intensity index is a lot more than we expect. The additional improvement is linked to energy investment. It has been Solomon's observation that many refineries don't always recognize the impact that excess energy consumption has on non-energy costs, such as maintenance personnel and chemicals. By not recognizing the true costs, many refineries underestimate the savings that could be realized through better energy efficiency, thus making it difficult to economically justify energy improvement projects. Improvements in energy efficiency can be made without large investments if energy upgrades are integrated into the life cycle management plans for each of your assets. There are many interesting observations for energy intensity index in the world's best analysis, and there is a lot of insight that we can share with you if interested. Unfortunately, we cannot cover them all today. World's best refineries did have a head start. They were already more energy efficient than the rest of the world at the start of the trend period. However, the world's best peer group is reducing energy intensity index at a much faster rate than the rest of the world average. 7 out of 12 world's best refineries have reduced EII by more than the rest of the world since 2012. 75% of the change in energy intensity index relates to a reduction in process duty. Now, process duty is energy consumed to heat oil products in refinery furnaces. Process duty can be reduced through good heat integration, which is linked to both equipment design and process utilization. I mentioned process utilization is 6% higher than the rest of the world, and we know that world's best refineries invest to improve equipment design, and therefore they can reduce energy consumption. Over 50% of the world's best trend group have invested more than twice the rest of the world average at some point since 2006. As well as this, they have higher heater efficiency. More of their electricity is self-produced, and they make a lot less steam through burning fuel. I showed you this chart at the start of the presentation, and as a reminder, the cost of transportation fuels is calculated from raw material costs, which includes crude oil, operating costs, and the additional revenue received through byproducts. And byproducts are all of your production that is not a transportation fuel, so it's gasoline, jet, or diesel. I trust by now that you appreciate why the control of costs through reliable operations is so important. I'd like now to talk a little bit more about these byproducts and how this too can help the long-term survivability of your site. Byproducts can be high value, such as chemical products or gasoline components, and that will reduce the cost of transportation fuels. Or byproducts can be low value, such as fuel oil, and that will increase the cost of transportation fuels. Our world's best refineries produce less fuel oil and less heavy intermediates, and they produce more chemical products compared to the rest of the world. One would assume that the world's best refineries produce less fuel oil by design. However, only 3 of the 12 refineries have got coking. There is also a wide range of crude types and qualities processed by each refinery. I'm sure that both of these factors will play a role in reducing fuel oil, but they do not distinguish the performance of the group. The only thing that I can say for certain is that all world's best refineries have got high reliability and they have got good economic optimization, which will definitely help to minimize fuel oil production. Non-energy operating costs were not a primary selection criteria, but just as we've seen in many areas, the world's best peer group is again first quartile in this metric. In fact, 7 out of 12 world's best refineries have first quartile non-energy cash efficiency index in their respective regions. To a large extent, this is driven by maintenance cost, but non-maintenance personnel should also be considered. At a high level, the world's best peer group appears to have average personnel numbers. They're sitting there between the second and third quartile breakpoint. And this position would be perfectly acceptable to many operators seeking to improve their competitive performance. However, if you filter out the refineries that have got really low wages and can afford to operate with increased numbers of personnel, there's a very different message. 10 of the 12 refineries in the world's best peer group have high wages, and more than half of these 10 refineries have got first quartile non-maintenance personnel. In other pieces of analysis that I've done for Solomon, I've discovered that a snapshot in time can be misleading. This only tells you what is happening now or what you can hope to achieve. There's a much more interesting story when you seek to understand why. World's best refineries don't start out seeking to have first quartile personnel. They arrive at this position after persevering for many years to change their culture and become highly reliable and an efficient operator. So in conclusion, what does it take to be a world's best refinery? Well, first of all, it is not size. World's best refineries are not different. They cover a range of size, complexity, and configuration. Could it be technology? Well, world's best refineries have invested in the right technologies at the right time for their market, and they operate them well. But the primary characteristic that differentiates world's best refineries from the rest of the world is reliability. Reliability improves gross margin. It improves energy efficiency, and it reduces maintenance cost. World's best refineries are also efficient. They invest in energy efficiency and other areas that are within the site's control. And last but not least, there's culture. Culture is the glue that holds everything together. World's best refineries have a culture that drives outstanding performance in many core areas of their business. World's best refineries are relentless. They never give up on continuous improvement. So as we look to the future and the 2020 Solomon study, we believe that this will be an unprecedented learning event. It will be fascinating to see how our world's best refineries respond to world's events. This will provide real insights on how they've managed their way through turbulent times. It is for this very reason why benchmarking in good times as well as bad is so crucial for performance improvement.